I wanted to go back to the beginning here just to clarify something. So when I drew the one solution for the two quadratic equations, something I need to clarify. I think I drew a picture that looked like this. So I had a quadratic that opened upward and another quadratic that opened upward that I said only intersected at once. Now be a little careful. If these guys have different steepness, they might intersect more than once. So what I'm looking at is two parabolas that have the same A value. If they have the same A value, they're going to be the same steepness. They're only going to intersect at that one point. So if the A values are the same, they will not intersect. If the A values are different, they could possibly intersect. So you have to look at the different situations. Okay? All right, let's move on to example 2. So this is our second video. We're on the back page. We're going to look at example 2. And again, I'm going to pull up my Desmos software and I'm going to graph these quadratics with that. So let me pull up my Desmos. All right, so I'm going to expand my Desmos. I'm going to graph the two equations, y equals x squared, here they are, y equals x squared plus x minus 1, and y equals negative 2x squared plus 4x plus 5. We have a system of equations because we have two equations. We're looking for where they intersect. So I'm going to pull up my Desmos and I'm going to graph those. So y equals x squared. Remember, shift and 6 will get you the exponent, but make sure you're back down from the exponent. Y equals x squared plus x minus 1. There's that quadratic. And the second quadratic, y equals negative 2x squared plus 4x plus 5. Make sure you have them typed in exactly correctly. Okay, so that's what our two graphs will look like. Those are our two graphs. So the red one is opening upward, the blue one is opening downward, so we know which one is which. Right? Okay, I'm going to draw those on my page. Oops, maybe I'm going to draw them on my page. All right, extend this a little bit, make it a little bigger. So the first parabola, y equals x squared plus x minus 1, has its vertex right here at negative 1/2, negative 1.25. It goes through the point 0, negative 1, negative 1, negative 1. And let's see, look at where it's going through. The intersection point 0.25. It goes through 1, 1. There's the point. I can't get it to click. But it goes through 1, 1, because 1 squared is 1, plus 1 is 2, 2 take away 1 is 1. It goes through the point 1, 1. Go through the point negative 2, 1. It's going to go through the point negative 3, 5. And there's that one. Okay. We can see where the intersection points are already. 2, 5 is an intersection point. I'm going to switch colors and do the other one in blue just like it is in my graph. Or maybe a lovely purple. So on the blue one, vertex is right here at 1, 7. Goes through the point 2, 5. Goes through the point where's another pretty point? Yeah, we could find another one. If we put in a 2, what do we get? 2, 5. We've already got that one. What if we put in a 3? What point would we get? Also, on the other side, we get 0, 5, right? Y-intercept is 5. We get the point, if we put in a negative 1, of negative 1 squared is 1. 1 times negative 2 is negative 2. Negative 2 take away 4 is negative 2. Plus 5 is negative 3. Are we right here? That would mean we have this point 3, negative 5, or 3, negative 3 over here. And where do they intersect? They intersect, let's find that point right there, negative 1, negative 1. It isn't negative 1, negative 3, it's negative 1, negative 1. Let's follow it through. Negative 1 squared is 1. Negative 2 times 1 is negative 2. Plus negative 4 is negative 6. Negative 6 plus 5 is negative 1. Okay. Negative 1 is our second intersection point. Let's draw the graph. And let's write down our two intersection points. Our two intersection points are negative 1. There's one of them. The other one over here, 2, 5. Remember, solving the system means finding the intersection points. The coordinates of those intersection points are negative 1, and 2, 5. How do we solve by substitution? Let's talk about that. So solving by substitution. We've got y equals x squared plus x minus 1, and y equals negative 2x squared plus 4x plus 5. Our two equations that we started with. We're going to solve by substitution. And we know what we're supposed to get. Let's talk about the process for getting there. So, the process for substitution is isolate or solve for one of the variables and substitute into the other equation. Well, my variables are already solved for y, or my equations are already solved for y, right? The y is already by itself. So I'm going to take this, I'm going to go over here and replace the y with it. So substitute, in place of the y in that second equation, I'm going to replace the y with what it is equal to. It's called substitution. Okay, now that I have this equation, I'm going to set it equal to 0. I'm going to switch back to a different color. I'm going to set it equal to 0 by moving everything to the left side. So to 0 out of negative 2x squared, we add a 2x squared. To 0 out of 4x, we subtract a 4x. To 0 out of positive 5, we subtract 5. So we're going to add a 2x squared. We're going to subtract a 4x. We're going to subtract a 5. So what do we now have? We now have 3x squared minus 3x minus 6 equals 0. We have it set equal to 0, so now we factor. Okay? We can divide out of 3 because there's a GCF of 3, so I'm going to factor out of 3. I could just divide it out and throw it away because 3 is never 0. So the only way this will equal 0 is if the x squared minus x minus 2 equals 0. So if you've got a constant like a 3, divide it out, throw it away. Okay, how do we factor that? We look at a times c. We look at the product of two numbers that create negative 2 but add up to negative 1. That's going to be a positive 1 and a negative 2. I'm going to draw my box and do my factoring. Okay. First term gets the first square. Last term gets the last square. Middle term gets split into an x and a negative 2x. GCF for each row, each column, and we've got our factorization. Double check it. X plus 1 times x minus 2 does equal x squared minus x minus 2. Okay? So, we set each factor equal to 0, and we solve those simpler equations. Subtracting a 1, adding a 2, all right, but we're not done because with each x value we have to have a y value to go with it. So we're going to plug back into one of the equations. It doesn't matter which one, so I'm going to pick the first one because it's a little easier. And I'm going to find the y that goes with it. Okay, so we have a 1. Take away a 1, take away a 1. That's y equals negative 1. right? So one of our solutions is -1, -1. Our other solution, when x is 2, plug in the 2. We get 4 plus 2, which is 6. Take away 1 is 5. So our second solution is the point 2, 5. Two solutions to the system of equations. All right, let's do the last one. Example 3. Once again, I'm going to go pull up my Desmos, and I'm going to graph those two equations. Y equals x squared minus 3x minus 2, and y equals -3x minus 8. If you don't have the note page and you're just doing this on your own paper, you'll need to jot those two down. I'm going to pull up my Desmos. Okay, I've got my Desmos again. I'm going to graph those two equations. Y equals x squared. Remember, shift and 6 gets you the caret mark, which is the exponent. That little looks like an arrow, top of an arrow pointing upward. Make sure you get out of the exponent position before you type in the minus 3x. So x squared minus 3x minus 2. There's that quadratic. And then the linear equation, y equals... See, did you notice the last two were both parabolas? This one's a parabola and a line. Should have pointed that out last time. They were both parabolas because they were both quadratics. This time we have a quadratic. So the first one we graphed was a quadratic. The next one's going to be a line. Y equals -3x minus 8. So that one's linear. Oh, notice what's happening here. The graphs are not intersecting. Let me zoom out a little bit. Notice they're never going to intersect. The parabola is going to keep getting steeper. The line's going to go the same slope all the time. Those two are not intersecting. So we're going to put them on the graph. Let me just set that. Okay, I've got my Desmos set up right here so I can hopefully do some good with this. I'm going to zoom out just a little bit. Zoom back in just a little bit. So we're going to graph the two. The quadratic has its y-intercept at -2, has its vertex right there at 1.5, -4.25. And it's also going to go through right here at 3, -2. That's probably good enough. If you want, you can put another point on that graph right here at like 4,2. Would that work? 4 squared is 16. Take away 12 is 4. 4 take away 2. Yep, 4,2. It checks out. So our quadratic, our parabola, looks like this. Sorry, it's a little wobbly. And then, I guess just to be consistent with what they've done on Desmos, I'll just use a lovely green. So my line has its y-intercept way down here at -8. Oh, it's off the graph. Could I find another point? Sure. If I plug in -1 for x, I get 3 take away 8 is -5. I go through 1, -5, and then I go slope -3. That means 1, 2, 3 up, left 1. 1, 2, 3 up, left 1. So I should get -3, 1. Do I? -3 times -3 is 9. 9 take away 8 is 1. Yep. Up 3, left 1. Get a nice accurate line. And there is no solution because these two graphs do not intersect. So no solution to the system of equations. Okay? No solution to the system of equations. All right, I'm going to get rid of Desmos. Sorry, pulled the trigger too soon on that one. I'm going to get rid of Desmos, and we're going to talk about how to solve by substitution on this one. All right, let's talk about how to solve this one by substitution. So we've got my two equations. Y equals x squared minus 3x minus 2. There's our quadratic. Graph was a parabola. Our second equation, y equals -3x minus 8.